welcome you all to this 91st special webinar under our flagship weekly series Engineers Talk, organized under the edges of Textile Engineering Division Board today in association with the Department of Textile Technology, K. Rangasamy College of Technology, Tiruchengodu. We are gathered here today as part of our 30th anniversary celebrations, a significant milestone that reflects our unwavering commitment to empowering engineers, enriching minds, and contributing to national development through knowledge sharing initiatives. Let me begin with an inspiring quote. முயற்சி செய்யும் கைதான் வெற்றியை பெற்றிருக்கும், முயற்சிக்காத கை வெறும் குறை சொல்லும். Only the hands that strive will succeed. Hands that do not try will only complain. Today's session is particularly special as we are joined by an esteemed academician and textile technologist, Dr. Chandrasekhara sir, Associate Professor, Department of Textile Technology, Babuji Institute of Engineering and Technology, Davangere, Karnataka. He is here with us as our chief guest and keynote speaker and will be delivering a talk on the very relevant and innovative topic, that is innovative weft insertion techniques for smarter weaving. We extend our heartfelt gratitude to Dr. Chandrasekhara sir for accepting our invitation and for sharing his time and expertise with us this evening. I also take this opportunity to thank our partner institution, K. Rangasamy College of Technology, Tiruchengodu, for collaborating with us in organizing this enriching session. I warmly welcome all distinguished faculty members, practicing engineers and professionals from textile sector, IEI members and our IEI committee members, student members and young aspiring engineers, and all passionate learners who have joined us today. We are confident that today's session will open new perspectives, spark curiosity, and inspire innovation in the field of textile engineering. Before we begin, a kind reminder, all participants will receive an e-certificate, and IE members with consistent participation will be honored during Engineers Day 2025 celebration. Let us make this evening meaningful with active participation and learning. Once again, I extend a warm welcome to one and all. Thank you. Jai Hind.
Thank you, sir. It's now my privilege to introduce the chief guest and keynote speaker of today, Dr. S.M. Chandrasekhara. He is presently working as Associate Professor, Department of Textile Technology, Babuji Institute of Engineering and Technology, Davangere, Karnataka. He did his bachelor's and master's in textile technology at Kuvembu University and completed his PhD at VTU Belgavi, specialized in bamboo fiber technology. He had been worked as Associate Professor at VTU Belgavi since 2006, with additional responsibilities as NAC Coordinator till 2022 and NBA Coordinator since 2022. He has published a book on bamboo fibers in the year 2022 at Wooded Publication. He is a member in Institute of Engineers India, Karnataka Local Center, and Indian Society of Technical Education. With these words of introduction, I would like to invite Dr. S.M. Chandrasekhara to present on the topic, Innovative Weft Insertion Techniques for Smarter Weaving. Over to Dr. S.M. Chandrasekhara. Please, sir.
Hello, good evening, everyone. I'm really honored to be present on the topic today, which is organized by the Institute of Engineers, Salem, Local Center, Tamil Nadu. The topic is on innovative weft insertion techniques for smarter weaving. It's a great opportunity for me. I am Dr. Chandrasekhara, working in the Department of Textile Technology, BIT Davangere. Today, I am sharing a few of the things which I know regarding this, the recent trends in the shirtless looms. Hope, I think my voice is audible, sir?
Yes, sir. Audible, sir.
Okay, thank you very much. So today's the topic is on innovative weft insertion techniques for smarter weaving. As my topic goes on like this: the introduction part, the classification of shuttle looms, and a method of weft insertion techniques of various recent shuttle looms like projectile, rapier, and the air jet looms. So here, before going to discuss in detail, my the I'm focusing the first point is why this kind of the shuttleless looms. What is the need of better weft insertion methods compared to this the conventional method of weaving? As we know, in the case of huh? ಹೌದಾ? See, my slides are sharing. Hello, hello.
Sir, no, sir.
Sir,
No,
no.
sir.
So 1 minute, 1 minute. Yes. So now slides are accessible.
Yes,
Yes,
sir.
sir.
Okay. See thank you. The first thing is, let me discuss why these better weft insertion methods are required compared to the conventional methods of weft insertion. As we know, in the case of the conventional shuttle based weft insertion, here in the case of the conventional, the shuttle which is having a more than a half a kg and which is introduced into the shed with a lot of acceleration, and I deaccelerated at the opposite side abruptly, and the weft which is available on the pond is only a few grams. Is to push these to carry the few grams of weft, the weight of half a kg, more than half a kg of the shuttle has to be pushed with a great velocity, and in the opposite side it has to be deaccelerated abruptly. So that's why the whole mechanism is shocky and noisy, and the process is inefficient. And during the time of deacceleration of the shuttle at the opposite side, most of these the thing is the energies get wasted at the swell mechanism, picker, and other the checking mechanism. So that's why the wear life of the picking and checking mechanism accessories are reduced, and the huge noise solution which makes the whole the area disturbed. And next point is the smaller weft package which requires a frequent replenishment. I mean to say, the weft available on the pern is only a few grams. It will be get exhausted within a 10 to 15 minutes, so that it requires the frequent replenishment. I mean to frequent replenishment, it is you have to change it as it is wound, as it is weaves down. There definitely it increases the load on the weaver and decreases weave room efficiency. And in the next case, what happens, the pick and pick, that is, the introduction of different color or linear density of the yarn into the shed, it is more complicated in the case of the conventional loom. As we know, the pick and pick loom or pick at will loom. So the shuttle looms requires more floor area, that it requires the permitting department and the personals required to carry the weft package. There is a chances of weft mixing. There is a chances of the variation from perm to perm. So this leads to the lot of the problem, and number of labors required to transport these the perms from permitting department to the weaving department. Definitely it increases the number of labors required for this the process. Then next thing is limited scope. I mean to say, limited scope means it is to increase the speed of the loom, and it is we have to increase this the picking mechanism, increase the picking speed. When you increase the picking speed, definitely there will be more vibration, and again we have to go for adapting the dampers on the loom. So that again it increases the cost of the machine, and again this the vibration on the loom. This is why the performance of the loom is also it is getting down, and the speed is also a limited factor. So especially the quality of the fabric, which is produced from the conventional loom is it's not of that good quality, and the major problem is width restriction. Why we cannot go for the higher width fabric? Because we have to push the shuttle for a quite a long distance is a difficult task. Why? Because we have to increase the speed of the picking mechanism. When you increase the speed of the mechanism, definitely there will be a great vibrations, and again there will be a more noisy, and so the problem will be like sudden at the opposite side of the loom stopping of the shuttle is a difficult difficult. So that's why width of the fabric is restricted in the case of the conventional shuttle looms. I mean, so keeping all this, the kind of the things in mind, people have thought, why can't we go for the shuttler's loom? I mean to say, the question is, it is to carry a few milligrams of weft. If you talk about the weft, the total weight of the weft for each peak, it is a few milligrams. It is to introduce a few milligrams of the weft. Why we have to go for a heavy, huge amount of the shuttle, and requires a lot of energy to push this the shuttle, and we require at the opposite the side of the mechanism, opposite side of the loom, we require the checking mechanism, because the speed of the shuttle has to be reduced gradually. So this whole process is making this the cumbersome. So that's why people have thought, why can't you design the loom with the no shuttle? That has come to the mind of this the mats. Then they have come up with this the new solution, that is what is called the starting the loom, or the loom with no the shuttle. That is what the introduction of the shuttleless looms into the textile. It is a major breakthrough, I tell you. In the year 1950s, it is with the great effort of Sulzer brothers of the Switzerland, they have come out with this the new solution, which is called as a projectile loom. The projectile loom is of the first category which are introduced into the textile market of the shuttleless the concept. Let we will go in detail for that the shuttleless loom. Before that, I'll just go through this the classification of shuttleless loom. The classification, first thing is the first kind of the generation loom is projectile loom. In that, the single projectile they have started. So when they started with this the single projectile loom, it was the projectile which has to be inserted into the shed, and it has to go to the opposite side, leave the FTR, and it has to come back to this the picking side, and again picking side again the great the wastage of the moment, great wastage of the moment. So that's why they introduce the multiple projectile looms, using of the number of multiple projectile. In the case of the multiple projectile looms, the number of projectiles decided by the width of the loom. Likewise, 5, 6, 7, 8 projectile are used in the case of the multiple projectile loom. Next category of the shuttleless looms are called rapier looms. So in that there is a big classification in the rapier loom. The rapier looms are classified on the basis of number, on the basis of weft, on the basis of rigidity. On the basis of weft, the rapier looms are classified as single rapier. They have tried with the single rapier. In that also, the lot of the time is get wasted, and then they have introduced the double rapier. Then they have gone for this the twin rapier. Then this the biface rapier. I'll go with this the small amount of the discussion, small discussion on those things in the next slide. Next is weft. Then the rapier looms are also classified on the basis of weft, method of the weft insertion. The two scientists which are found out the different concept of weft insertion. One is called the Gabler system, and other one is called the Deva system. In the case of the Gabler system, the method of weft insertion is called loop transfer technique. In the case of Deva system, the method of weft insertion is by tip transfer technique. This is the classification of rapier loom on the basis of weft insertion methods. On the basis of rigidity, The rapier looms are classified as rigid rapier, flexible rapier, and telescopic rapier. So, where in the case of the rigid rapier, the space required for the loom is more. So that's why that is the limitation of the rigid loom. And next they have gone to this, the flexible rapier. The rapiers after the insertion are wound at on the flexible tape. That is what is called flexible rapier. And in the next case, the telescopic rapier, it is like a telescope. See, the weft which is inserted by the rapier, which will be completely pushed in the telescopic tube. That is what is called, the telescopic rapier. So this is regarding the classification of the rapier looms. Next comes, the jet looms. Jet looms, in the case of jet loom, there will be two category. One is air jet loom, and other one is, the water jet loom. So in the case of recent times, the last the 4 to 5 years, especially the air jet loom contribution into the market is wide and more. Why? Because the air jet loom, especially for the apparel application, people are preferring air jet loom. Why? Because the major advantage of the air jet loom is a higher weft insertion rate, that they have gone up to the 2000 meters per minute, and the production is more compared to this, the projector and the rapier, and especially for the apparel application. And present days, the air jet looms are ideal. So in that case of, the air jet looms, the classification of the air jet loom is using of single nozzle, confusers, and relay nozzles. The air jet looms are classified. And another kind of, the jet loom is called water jet loom. Water jet looms are, major problem with the water jet looms are, they are restricted, especially only to this, the hydrophobic yarns, like, the polyester and all the thing, because they are not recommended for the cellulosic materials. Why? Because the problem, the whole media is water, so that's why they may get, the absorb the water and make this the cloth wet. So that's why the water jet looms are restricted only this hydrophobic yarns. That is one limitation in the case of the water jet. And, the width restriction. But where in the case of the air jet loom, first they have tried with some of the 230 centimeter wide fabric. Now by introducing fusers, relay nozzles, and multiple jets, they have gone with this, the wider width in the case of the air jet loom. Next comes, the multi-phase looms. Multi-phase looms, multi-phase looms are very popular for higher production rate. So believe it or not, the multi-phase looms, they have gone up to the speed of 5,000 meters per minute in the case of the multi-phase loom. That is the classification is one is warp way and, the weft way. In the case of weft way, there is a rectilinear and, the circular kind of the multi-phase looms are also available. And next comes, the triaxial. And next comes, the weaving cum knitting and solid friction. So these solid friction and weaving cum knitting concepts are not much into this, introduced into the market. They have to get to popularize. But rest of this, the kind of the shuttleist loom, like projectile rapiers, especially projectile looms, which are very popular for wider width projectile and the rapier. They have gone up to the 5,000 meters, 5,300 mm. Wider width cloths are, the possible by using projector and the rapier. So this is what the brief classification of the shet looms. So this next slide shows, you can just see in the this is the projectile. This is the projectile which catch hold of the weft yarn from the one side of the loom and introduces the weft in across the shed and leaves the weft yarn, and this projectile will fall on this the conveyor belt and come to this, the picking side once again. And the second diagram shows the rapier. This is the rapier which will catch hold of the weft yarn. This is the single rapier which is shown here. There are double rapiers, which one rapier is collecting the weft yarn from the picking side. Another rapier which comes from the opposite side of the loom. Both are meet at the center and the transfer takes place. Here there are two methods as I mentioned already. One is a loop transfer technique, that is what is called Gabler system, and another one is called, the tip transfer technique, that is what is called, Deva system. So anyway, the transfer takes place at the center of the loom. In the case of the double rapier, this is the beginning of this. When the rapier started, they have started with the single rapier. Now the rapier looms have gone a lot of the changes, like introducing of double rapiers, twin rapiers, and the multi rapiers. Now you can see the third photograph. This shows the air jet loom, the principle of the weft insertion using of the jet. This is the main nozzle, and the weft is introduced by the pressure which is created from the main nozzle. I'll go in detail this the thing, and the weft is introduced into the shed by the nozzle, the pressure which is created by the main jet, and in between that there are relay nozzles are available, confusers are also available, and the air guides are also available. So because of all this the accessories in the recent edition, and they have gone to this the wider width fabric in the case of the air jet loom, and this is what is called the water jet loom. Here the pressure created by this the jet point here, the which carries the weft arm across the shed. This is these the four the diagram shows the different types of the weft insertion method by using projectile, by using rapier, and by using air jet, and by using the water jet. So here I'm just just go through this. What are the features of this the unconventional weaving machines? How they differ from this the conventional weaving machines. So first thing is the unconventional weaving machines, which they carry the large weft package like the cone or the cheese. Cone or the cheese which containing huge amount of the weft yarn, they can supply the weft yarn for quite a long period. I mean, the cheeses or the cones, they are weighing nearly about 5 kg, 6 kg cone, so that they continuously supply the weft yarn. That is what the advantages. That is what the important feature of unconventional weaving machine. Next one is unconventional selvage. As in the case of the conventional selvage, we have the continuous weft insertion by the shuttle. The loop kind of the selvages are formed in the conventional one, but where in the case of the unconventional selvages, there are different types of selvages. I can quote them. They are tuck-in selvages, leno selvages, fused selvages, melt selvages. Likewise, the different types of selvages which are made very attractive near the selvages. They can go for monogramming, and they can do some the kind of the blend composition or whatever the things they wanted, or company name they can put it on this so beautiful attractive selvages are formed on the recent unconventional shuttle's loom. Next one is weft accumulator. The use of weft accumulators, they store the required amount of weft yarn from this in the cone of the cheese in advance, so that total average weft tension is reduced by using of weft accumulators. That's what the advantage of using weft accumulators, especially in the case of jet looms. I'll tell you, in the case of air jet and water jet, weft accumulators are must. But recently, in all the cases of the unconventional, like in the projectile rapier, air jet, or water jet, weft accumulators are available. They stores the weft required for each pick in advance. That's why the overall average tension is reduced on the weft. In the weft. That's why the weft accumulators are now used. And weft cutters, the weft cutters sometimes they are provided at both sides of the loom or at one side of the loom. So the weft cutters are provided. So these are the this thing important features of the unconventional weaving machine. That is what large weft package, which is called cone of the cheese. Sometimes they are provided one side or both the sides. I'll tell you one more point is, they are provided with the magazine creel. You just imagine, so each package position is duplicated. Thereby the weft can be supplied for hours together, or shift together, or days together, by using the magazine creel. So that's what the advantage of the large weft supply package like cone or the cheese. And the whole purwinding department is eliminated. The people required to do the purwinding and machinery and the transportation, then chances of weft mixing, all these things are completely eliminated. So that is what one way you can increase this, the efficiency, or we can get, the good quality fabric, because when the purn is exhausted, when you change it, there is a chances of, the variation in the peak density or variation in this, the changes when the weft is purn is changed. So that's what I've just mentioned. Constant tension is maintained because of the weft accumulators. Salvages, very attractive salvages are, the form using of the modern or unconventional shuttle looms. So I'll move on to this, the projectile looms. The projectile looms are introduced into the market by Sulzer brothers in the year 1953, Switzerland. The projectile looms revolutionized the weft insertion technique in the complete the weft insertion method. It uses a projectile to insert the weft yarn through the warp shed. So, in the case of the projectile looms, you imagine the just imagine the projectile dimension is 90 mm. What I mean to say is what is we have to observe is, see, more than half a kg of the shuttle, which is used to carry the few mgs of FTR, is reduced to 90 grams. It is reduced to 40 grams. The weight of the projectile is reduced to 40 grams, where the shuttle, it is almost a 1 feet length, it is reduced to 90 mm. And width of the shuttle is width of the projectile is also 14 mm and thickness is 6 mm. By just observing this, the dimensions of the projectile, to greater extent, all this, the projectile, the shuttle dimensions are, they reduced. I can justify it because of this, the reduced the weight of this the projectiles compared to this, the conventional shuttle. It is able to pass throw this, the projectile into the shed with a greater velocity. And these the projectiles which are made of steels, no question of, the corrosion, and they are used to carry the weft yarn across the shed. There may be projectiles of single or, the multiple projectile on the basis of the width of the loom. Maybe like as the width goes on increasing, the number of projectile goes on increasing. That is what is, the basis to select the number of projectiles. In the case of the projectile, see, one more very attractive point is the projectile, the powered by, it is, the passed through the shed, it is by using of, the torsion rod, torsion bar picking mechanism. It is one of the very attractive point on this, the projectile loom. The torsion bar, which is made up of various splice and steel, which is fulcrumed at one end, and the other end of this, the torsion rod is twisted to at an angle of 15 to 30 degree. How much of strain energy is required? On the basis of that, the projectile, the torsion rod is tilted, and it will be suddenly released. So whatever the amount of the strain energy which is accumulated when the torsion rod is twisted, that strain energy is used to push the projectile across the shed. So that is the new kind of the projectile picking mechanism used in the case of the projectile looms. And the projectile guides are provided, because when the projectile is moving across the shed, by any means the projectile should not fall, because the projectile is moving at a very greater velocity. It should not fall in between that, that's why the projectile guides are used. So the projectile guides are stationary during the picking mechanism, during the pick insertion. Once the pick is inserted, the projectile guide rack is pushed down, and there is no problem for the beat up mechanism. So here, in the case of the projectile loom, it is the weft is, I just go through this, the weft insertion mechanism. The weft is directly drawn from the stationary supply package and introduced into the shed, and the no question of any department is required here. directly the cones or the cheeses are used as a web supply package. It may be of using of single pick, or it may be of the multiple the projectiles. And facility for multiple pick in the same shed is also possible. Tuck in salvages, please understand, the projectile looms are very popular, especially for making the tuck-in salvages. Tuck-in salvages, the how this the tuck-in salvages are formed. So when the weft is inserted at both the side, a small amount of weft is protruded. I mean to say 10 mm this side and 10 mm this side, and that the extra weft which is introduced, that will held by the tuck-in needles and introduced into the shed when the next shed is open. The strong, neat, attractive selvages are formed by using tuck-in concept, tuck-in. And another the feature of this projectile loom is pick finding mechanism. I mean, pick finding mechanism. If there is any fault in the weft, any fault in the pick, the loom is allowed to run back one or two pick. You can just repair it and then run the loom. That is what is called pick finding mechanism. And take up beam can rotate in reverse direction to assist the pick finding mechanism. And shedding and reed motion. Here clay carries the reed and projectile guides. So that is another attractive point. And the reed is reciprocated by a pair of cams in the complete width, and reed remains stationary during the picking insertion. And we can get a dwell of 255 degree at the back center. So that is what so we'll get a lot of dwell period at the back center of the loom. That means that we are providing the projectile looms to projectile to pass across the shed. Greater time is given for the projectile. So that is why more time, and say it is because of this greater class are possible because of this we can design the reed, and as well as the according to our requirement, so we can design, so we can get the 255 degree dwell at the back center. Production speed is the weft insert rate is 900 to 1500 meters per minute. So greater the weft insertion this thing is available. 900 to 1500 meters per minute weft is inserted, and this is what it is additionally increase this the efficiency and the production. And benefits are smaller shed depth reduces the work tension. So depth of the shed requires is very small because the project is like a bullet which carries the weft yarn across the shed. So it does not require any heavy shedding mechanism. So that's why the strain and the warp is reduced. When the strain and the warp is reduced, breakage rate of the warp is reduced. When the breakage rate is reduced, the stoppages of the loom is reduced. When the stoppage of the loom is reduced, definitely the weave room efficiency is increased, and the less breakage rate and leads to the good quality cloth. So that is what is the advantage of this the projectile. Compact weaving width options are possible. I mean to say, so you can see if you have the 230 centimeter wider width loom, you can reduce the width of the loom according to requirement. That facility is available. That is what one advantage. Simplified color changing mechanism. I just mentioned when I comparing this, the shed looms. So there, the picking mechanism and as well as this, the color changing mechanism, that is pick and pick loom, pick and pick insertion is more complicated in the case of the conventional loom, but where it is very simplified. People in the recent machines, people have gone for 12, 14 the color options in the web direction. That's what the advantage of the using the projectile loom. This is what the brief introduction, brief the discussion on the projectile looms. So here, my humble request to this all the participants is whenever any doubt or this thing want the ask something, you please ask me. Yeah, I can answer your queries, or else I'll go through the next slide. So next slide is the concept of weft insertion is by rapier. The rapier looms, recent time very advantageous, and they are more widely accepted, especially for apparel fabric, the production compared to the industrial textiles. And it's a new approach in the complete weaving concept. Here, the weft is secured in a slat of a stick, which is manufactured by using the carbon, the material. It is weft is the caught by this, the rapier, and rapiers maybe a flexible tapes or maybe the rigid rods. It is according to the type of the rapiers which are used, and they are made up of coated steel reinforced with high performance man-made fibers like the carbon. So inventors, Mr. John Gabler in 1922, he has introduced the concept of loop transfer, and Raymond Devas in 1939, he has introduced the trip transfer, the technique. Compared to this, the loop transfer technique, the tip transfer technique is, popular and easy to transfer the weft yarn. And I've already mentioned that the classification of rapier weaving machines are based on the number of rapiers, method of weft insertion, and type of rapier, positioning of weft insertion mechanism. This the classification I've already given, and so I'll just give the brief, the features of all kind of the rapier looms, and you they see that increased weft insertion rate of 1,400 meters per minute, and the speed they have gone up to this 900 rpm. So where in the case of the conventional shed loom, people are finding difficulty to achieve the 200 to 230 rpm. When they have gone behind this the 300 rpm, they used to get a lot of vibrations on the loom. So that's what the biggest problem in the case of the conventional shuttle. You just imagine 1,400 meters per minute weft insertion rate and speed of 900 rpm. It is the amazing, and see that the width of the cloth. It is 5,400 width as possible. I mean, in the present context, people have they are trying this, the three cloths at a time on the same loom is possible. That's what the beauty of the unconventional looms: less noisy, less wear and tear, and the flexibility and wide applicability. What do you mean by this? The flexibility and wide applicability, and so they can use it for different types of the variety of yarns, and they can go for different application, different application. The fabric can be produced on the loom. So these are used, the say rapier looms are used for to produce the fabric for different application, and you see they can go up to 14 colors easily. See this, the color options of up to 14 colors, and synchronized driving system. This is one of the attractive point. Synchronized driving system is what the shedding mechanism, picking mechanism, beat up, let off, and take up mechanisms are so much synchronized. So because of this, the synchronization, they can run smoothly and they can go without any defect, and they can get into the higher production. These are all the possibilities in the case of the rapier looms. It can produce, it is possible to produce less defects. So because of the less defects, less value loss, and less the defect, so that they can make profit, more profit. That's what the advantage of using the rapier loom. Easy supervision due to signaling system. So your signaling system is made especially for the weavers. The signaling lights are available. So the particular defect, particular the light will be illuminated, so that particular problem will be rectified, and the weaver can attend that particular problem. That is what one attractive point of the using of signaling system in the case of the all kind of the recent loom. And easy machine width changing. I mean to say, example is easy machine width changing. You are working with the 600 width fabric. Your machine, the width of the loom is 600 If you want to reduce it to the For 400 mm, it is possible. That's what. I mean, changing of width of the loom is available. That possibility is available. That is another point. Bigger size of warp, more amount of the warp available, so it can run for very long time. And bigger size war beam and bigger size cloth beam, more running time, so it can reduce the downtime. I mean to say, you can the loom for a quite a long time. That is what the another advantage of the rapier loom. Reinforced heavy duty versions, I mean, the meaning is the construction of the loom is made heavy so that they can go for heavy density fabrics. I mean, they can go for heavyweight fabrics like denim and all things easily, and they can produce, the industry fabrics. It is because of the loom is sturdy. It is because of the functions of the looms. The parts of the looms are made by heavy duty versions. That is the another point is here. The whole driving system mechanism is kept in centralized oiling system. All the moving parts are receiving the oil, lubricating oil automatically. So that's why no need of oiling frequently, or the hands of the operators are get dirty and they may soil the fabric. That kind of the problem is completely solved. And dry lubrication for repairs, that means the using of graphite dry lubrication, using of graphites, the repairs are lubricated, less maintenance and longer life, so the machine can have a longer life. So I think one point when I'm mentioning the first slide, the space, the wearer life of this, the looms parts are less in the case of the conventional loom. It is where you just compare here the lifespan of the looms, rapier and the projectile is more clean and pleasant working atmosphere. So this is, I mean to say, the working atmosphere is very pleasant, so that is no noise, and so the worker can be comfortably work in the weaving shed. Clean and pleasant atmosphere, another advantage. Less chances of accidents because the signaling system and push button operating system, all these things are made easily in the case of the recent loan. It is easy setting and simple to operate. So no need of, like in the case of the conventional loom, to stop they have to push the handle to the off position, and when they want to start they push the starting handle to the off on position. Though that problem is completely ruled out in the case of the rapier and the projectile. Slow motion for the inspection and setting is that provision is made in the case of the rapier loom. That is one I mean, if you bring this machine to the slow motion, you can visualize, you can inspect the defects, or you can make some small repairs when the loom is running. That's what the advantage of the slow motion provision in the case of the rapier loom. Suitable for quick style changes, it is very advantage. Both, it is not bolt, it is both warp and weft designs can be changed when the loom is running. See, the loom is attached with this, the small computer. All the data are stored in this, the computer. Whenever you want, you can change this, the designs in the web direction, and you can store 30-40 designs in the computer, or a number of designs according to the capacity of the machine and the capacity of the computer. So you can change the designs. Rapier its size is it is a reduction in the size, reduced power consumption, and reduced salvage waste, electronically controlled drive for let off and take up mechanism. So this point again I take 1 minute here. So here server motors are used, electronic let off and take up mechanisms are installed. So thereby the tension variation, any kind of the variation in the tension in the case of the let off mechanism is identified, and in the meantime it will be the tension is regulated, and the required amount of the warp is suddenly released to the weaving area. And same case with this the take up mechanism also. So this leads to the less breakage of warp and the variation of peak density in the case of the take up mechanism. So that's why you can the reduce this the defects in the fabric. auto adjustment for warp tension and density when the loom is running. So these provision is it is available. You can adjust the tension of these, the warp, and you can reduce whenever the warp tension is reduced. Signaling system will show. Whenever the tension is increased, the signaling system will show the showing that the tension is more and the tension is like, so that accordingly the viewer can adjust the tension, the low or when it is high. These kind of the provisions are available. So these photographs shows the weft insertion, the technique on this, the rapier loom. You can see this is what is called, the creel, which is available to keep this, the supply package. And this is again depends upon the capacity of the machine. They have up to 14 colors or 12 colors, 14 colors or 12 cones or cheeses are provided here. And this is what is called, the confusers, the accumulators, which can store the FTR of required amount here, and then the weft is collected with the rapiers and introduced into the shed. This is what is, the photographs which will show the weft insertion. And here the small, the symbolic representation how this, the rapier looms are working. This is the rapier insertion. Here you can see this is the one rapier and this is the another rapier which is coming from the picking side. And the this is the weft yarn. When they come at the center, the weft is released and taken by the opposite rapier, and the opposite rapier which catch the weft yarn and extend the weft into the next half of the shed. So this is the weft insertion by single rapier, and this the kind of, the rapiers not much used in the industry. Why? Because here greater time is get wasted in the case of the single rapier weft insertion system. Here in this case, the weft has to caught, weft is caught in the slot of a rapier stick, and the rapier carry the weft yarn and leaves the weft at the opposite side, and the rapier will come back in the same shed. Here, in the next year, you can see the rapier comes from the same year. This is the supply package. I mean to say the cone, and this is the rapier which comes from the opposite of the loom, collect the weft yarn and draws the weft in the rest of the shed. This is what is the same. The rapier is at opposite side. Here the rapier is at the same side where the cone or this, the package is provided. So here this is what is called, the twin rapiers. This is made possible. This the advantage is here the very good, the space utilization. And you can see at the center the weft insertion complete mechanism is available at the center of the loom. So these are the two packages. The only thing is phase change here. So whenever this left side loom is working, the right side, the opposite phase is working. What I mean to say is here the picking is inserted this side, and this side the beat up and the beat up is over, and the takes place in the case of the rapier weft insertion method. This is what is called the biface rapier. And I'll move to the next one. And this is the gabler system of the rapier. So this gabler system, which will explain you the loop transfer technique. And I think the photos are very small, which maybe not be visible to see. Imagine this is the loop transfer technique. See this, the rapier. This is what the picking side, and this is what is called offside of the loom, where this, the projectile is coming here, coming to the center, and from this side one more projectile is collecting the weft yarn and meet at the center. The opposite rapier collects the weft yarn and draw the weft into the rest of the shed. These things are explained in the 8 stages. This is what is called gabler system of the rapier technique. And I'll move to this weft insertion by air jet. So in the present context, many of the manufacturers are going for air jet, the kind of weft insertion. Why? Because the major advantage is the higher weft insertion rate. As I mentioned, they have gone up to this the 2000 meters per minute. As the air jet loom, after the projectile and after this the rapier loom, next kind of generation looms are the air jet looms, which are into this the shuttless loom category. They are introduced into the market in the 70s, early 70s. Wide range of the fabrics can be produced by air jet looms, and higher weft insertion rate of 2000 meters per minute. And earlier they have started with this the single jet, and that the using of single jet width restrictions of 150 centimeter. In the later cases, they are using confusers, they are using relay nozzles, they are using the multiple nozzles. They have gone up to easily 400 and 500 centimeter wider class by air jet loom. So that's what the advantage of the air jet loom. And the noise level is very less than 5 to 10 decibel. So that is why the working atmosphere is very nice, and it is a pleasant atmosphere. People are working in the air jet loom shed comfortably, because of low noise. Why? Because no noise. The depth of the shed which is required is very small. Why? Because there is no weft carrier devices are available to carry the weft yarn. Weft is drawn through the shed by using only a pressure of jet. So that is the one major breakthrough in the case of the air jet loom. In the year 1914 itself, the Broke has attempted. In 1929, it was patented by Balu, and later, so Maxbo Murata company, which were introduced this, the air jet looms into the market. The people still call it as the Murata air jet loom, Murata air jet loom. Why? Because it is a Maxbo Murata, one of the company which is commercially the release this the looms, air jet looms into the market. So that's why they are called Maxbo Murata jet loom. And I'll go through this, the salient features of air jet loom. Reed space maximum of 400 centimeter. People have gone. Speed of the loom is 700 rpm. Very attractive feature is 1600 to 2000 meters per minute. Weft insertion rate is more attractive, and shedding by crank, cam, dobby, or jacquard. So it made possible to go for wider varieties of the cloths, except the heavyweight fabrics. You see that the point height of the shed is very small. Why? Because it doesn't require any heavy shedding devices, because no question of any carrying devices are available in the case of the air jet looms. So that's why it is made very attractive. The depth of the shed is very less. So when the depth of the shed is very less, the strain and the warp is less. And when the strain and the warp is less, the breakage rate is low. When the breakage rate is low, the production rate is high, and the less valueless defects are less, and definitely the good production, and great. This thing because of the increase in the efficiency, it is very advantageous. The market and this the company. Weft insertion by using single or multiple jet confusers and measuring system. I mean to say measuring system, it measures the amount of the weft required for each weft. Accumulators which stores the weft in advance for each week, and there are feeders are available to feed this the weft to the jet point. Here compressed air supply. Please, note those, the point. Compressed air supply means there should not be any oil, there should not be any moisture, and it is completely dry, oil free. Of 6 bar pressure is required at the time of jetting. That is one, the point requirement, 6 bar pressure. And the weft stop motion and the warp stop motion by optical and the electrical. So whenever it is the warp break occurs or weft break occurs, the loom will come to halt immediately. So it made the possibility of stopping the loom immediately, so that the operator can stop the loom immediately. So here then The servo motors, the electrical type of let-off mechanism, which regulate the tension of the warp yarn so that the tension in the warp yarn is properly maintained. Positive continuous electronic take-up mechanisms are made, available, and so that there will not be any variation in the peak spacing. There will not be any variation in the peak density. Whatever the expected, the peak spacing and peak density is possible because of the positive continuous electronic take-up mechanism. Peak finding device, I mean, you can forward and back, inching forward and backward by using a peak finding mechanism. So that is what the greatness of this, the air jet loom. And Leno, more popularly, melt salvages are more useful in the case of the air jet loom. And it is the whole driving system is through a V rope, so it is made smooth running, and push button start and stop. See another attractive point: emergency warp stop release of the starting mark to avoid this, the starting mark. This you can compare to this, the shed loom. In the case of the shed loom, is whenever you start the loom, stopping it and repair it and starting the loom, there is a chances of in the starting mark at the time of the restarting the loom. That problem is completely rectified here, and centralized lubrication system is made possible to supply the continuously oil or lubrication to all the working the area, so that the room runs smoothly. So that is what the possibility of getting very low noise. Major components are running in the centralized oil bath, electronic control, microprocess control, weft insertion timing, and pressure functioning detect the cramper opening and closing using of microprocessor, signaling system to identify the faults. You see that the less than 50 decibel made it the pleasant atmosphere, and the fabrics woven using of the air jet looms are cotton blended, spun filament fabrics, poplin, taffeta, denim, fancy, etc. are possible using of the air jet looms. This is the small photographs which are shown in the figure, which explain you shows this the air jet loom. And you see this, these are the weft supply packages. This is the main jet which the collect the weft and push the weft across the shed. Confusers are available, relay nozzles are available, and this is the main the jet which creates the pressure of 6 bar in the case of the air jet loom. So this is the schematic diagram which explains you the method of weft insertion across the any air jet loom. This is the weft supply package, and this is the main jet, and this is the highlight, and C is here the weft yarn, and these are the different stages of WFTR, and this is the read. First stage shows the WFT is ready to push, and here the second, the WFT is pushed across the worksheet. Read is coming to the front center, and in the third case, read come to the front center. In the fourth case, read is pushed the WFT to this the fill of the clad, and you see this this photograph here. The cutters are cutting the WFT on the both side, and the next figure shows the repetition of the same the first process. This is what is the weft insertion technique in the case of the air jet clones. So next come to this, the water jet looms. The water jet looms were introduced into the market in the year 1955 by Swathe. So that's why they are popular as Swathe water jet looms. In the year 59 in Czechoslovakia, 60 looms are introduced into the market, and here the weft insertion is completely water jet. This is what the biggest limitation in the with this the water jet looms. Why? Because they are not recommended for the cellulosic material. They are restricted only to the pure synthetics, That's what the problem, and the width restriction compared to the air jet loom. So that is why water jet looms are limited in use only wherever this the polyester and polypropylene looms are the fabrics are woven. Water jet looms are the recommended. I'll quickly go through the requirements for the to weave successfully on the water jet loom. Warp and weft yarns must be water insensitive. I mean to say they must be hydrophobic in nature. They should not absorb the water, and even if you size it, they should be sized using of synthetic sizes only. They are recommended only for polyester, nylon, etc. Corrosion resistance, all the metallic parts, all these, the loom parts should be completely corrosion resistance. Example, stainless steel or coated materials. This made this, the cost of the loom increase high. Why? Because the all parts of the loom must be corrosion resistant, or they have to go for stainless steel. Here, miniature pump is required. It is miniature pump. It is to pump this, the water, and the main important thing is here, it is the whole process of weft insertion system. In the case of the water jet loom, it is based on the amount of the water, the pressure under which the water is jetted. It is design of the nozzle, timing of cramper opening and closing the the uh, nozzle, and measuring length of the yarn, nozzle position and direction of the yarn flight will decides the weft insertion methods and the technique. But the thing is here, the compared the air jet loom requires compressor. This the water jet looms requires the miniature pump. Here the it requires a demineralized plant. Here why demineralized? If it is minerals are left in the water which is used for the weft insertion, like in the the calcium and magnesium, which make the nozzle the corrosion, and they may obstruct this the movement of the weft yarn. So that is why it is the demineralized plant is required, and the pH of 7 is recommended, and it should be the all loom parts should be corrosion resistant. Either it has to be coated. So these are all the few key points we have to take care in when we weave with this the kind of the water jet loom. So this is all my in my presentation. And if it is any like the things are wanted to share, please ask me regarding the my presentation. Hello. Hello.
Sir, சொல்லுங்க சார்.
Yes. Yes, sir. Hello, sir.
Yes, sir.
This is the complete presentation on the topic of the shuttleless loans.
Okay, sir. Well, sir, thank you, sir. Then, is there any queries, sir, please, from the participants? Okay, then let's conclude. Thank you, sir, for your resourceful presentation on innovative weft insertion techniques for smarter weaving. And now I would like to invite the Honorary Secretary, IEI Salem Local Center, to propose vote of thanks. Please, ma'am.
Thank you, sir. Am I audible, sir?
Yes, ma'am. Yes.
Most respected our chief guest and keynote speaker, Dr. Chandrasekhara, sir. Respected Chairman, Dr. K. Tangaraj, sir. Respected committee members from state and local center. Respected Arumugam, sir. And Mr. Tyagu and students from various organizations. Good evening to all. It is my distinct honor and privilege to deliver the vote of thanks for today's enlightening seminar on innovative weft insertion techniques for smarter weaving. This is 91 special webinar under the aegis of TXDA. First and foremost, I would like to express My heartfelt gratitude to our esteemed speaker, our chief guest, Dr. Chandrasekhara sir, Associate Professor, Department of Textile Technology, Babuji Institute of Engineering and Technology, Devangra, Karnataka, for taking the time to share your expertise and experience and practical knowledge with us. Thank you so much, sir, for gracing this occasion and sharing your invaluable perspective with us. Your presence has truly made this event special. You have provided us with a comprehensive understanding of the latest advancement in the WIFT in session technology. Thank you so much, sir. Our heartfelt thanks to our beloved chairman, Dr. K. Tangaraj sir. He is always driving force behind all for all the successful programs organized by IEI Salem Local Center. Thank you, sir. I convey my special thanks to Dr. Suburaya Saran, sir. Sir is the a professor from Textile Technology, KSR College of Technology, for introducing our powerful guest. Thank you so much, sir. I extend my sincere thanks to our engineer talk team series, Dr. R. Satish Kumar, sir, Dr. A. Kumaravel, sir, Engineer N. Arumugam, sir, Engineer K. S. Selvam, sir, for their contributions and guidance always. It's my privilege to thank Engineer Arumugam, sir, for his continuous support throughout all the events of our IE Salem Local Center. Thank you, sir. I would like to place an appreciation to Mr. Thiagu for his dedication, which is highly commendable. Thank you all once again for making this seminar resounding success. Thank you.
Uh,
Thank you,
I,
sir.
yeah, I take a moment to thank you.
Okay, sir.
I'm really honored to be a part of the Institute of Engineers. I am executive member of Institute of Engineers Karnataka section. It's a
Oh,
great honor to me, and it is a great opportunity to share a few things along with all the people. Thank you, madam. Thank you.
thank you so much, sir. It's it's fortunate for us also.
And I sincerely thank all the team members of Institute of Engineers, and especially my sincere thanks to the Subbarayan and Tangarajan, who are all invited me to give a talk on this the topic. I thank one and all once again. Thank you very much.
Thank
Yeah,
you, sir.
thank God, sir.
Okay, sir. Have a good day.
Yeah, thank you, sir. Thank you, ma'am.
Thanks, sir. Thank
Arun,
you,
sir,
sir.
thank
Thank you.
you.
Thank you, sir.
Thank you, sir.
Subrahim,
Thank
sir,
you.
thank you, sir.